Alrighty. So, hi everyone. Thank you so much for joining us today. We're very excited to be launching our new data analysis products, including virtualization, which I think we're most excited for. If you're wondering what exactly that means, don't worry, you're likely not the only one. We consider it a pretty milestone achievement in this space, and so we're really pushing the boundaries of lab data management and analysis beyond maybe what's familiar and beyond how we kind of think about it today. I think while we wait for everyone to join, I also have two sort of icebreaker style polls you should be able to access and respond to on the bottom right. Just trying to get a sense of, improving our outreach efforts and what maybe piqued your interest in joining our webinar today. And then in terms of the agenda, so our co-founder and CEO, Nathan Clark, he'll start us off with a primer on where the industry is today when it comes to lab data analysis. And he'll be focusing in on flow cytometry as a representative case study. He'll illustrate why we've taken this new approach to offer scientists the most comprehensive data analysis experience. At least that's what we think. And then Nathan Ballou, our scientific solutions engineer, who does a lot of our implementations and somebody you'd be able to work with should you choose to kind of collaborate with us. He'll be providing a demo of our new analysis products. And then finally, we'll provide a roadmap for how we actually intend to integrate these new products and do a live Q&A. So without further ado, kick things off to Nathan Clark.
Thanks, Alan. Yeah, great to meet everyone here. Good morning, good afternoon, and good evening, depending on where you are in the world. I'm really excited today to be announcing some of our new products here. And I will jump into a deck that we have to go over some of this. Let me open this up. So Ganymede, for those that don't know, we are a data and integration cloud for science and manufacturing. We provide the infrastructure, the connectivity, the solutions to really bring everything together in your lab and in your manufacturing site, bring all the data into one place, and drive automation and analysis on top of that. One of the things that we've always been inspired by is really understanding very, very deeply what are scientists doing with their hands? How are they spending their time? What inhibits the actual scientific part of accelerating R&D? And if you break it down, based on what we've observed in our clients and in our market research, a substantial amount of time is not just spent at the bench, but managing and working with data. We would estimate around 15% of people's time is spent on various data entry and data management tasks, moving data from A to B, entering data from one tool to another, trying to figure out where data is, trying to figure out how to collate or create the data set that they need, finding data from public sources. This takes up a fair amount of people's time. And that's a lot of what Ganymede historically has been able to help with, is connecting data from instruments, from applications, from databases, bringing it all into one place and making it fair. But there's another 20% additionally of time that people spend analyzing the data. And that analysis is much harder to pin down or automate because it's very open-ended. Scientists spend a tremendous amount of time using analytical apps, working on things in Excel, building visualizations, building PowerPoints, using scripting and other code-based tools to process their data. And some of that can be automated in tools like Ganymede or through scripting systems that folks may have. But much of it always needs to be human in the loop. That is a lot of what the scientific expertise goes into, is determining how to do the analysis, how to figure out what you're looking for. And so we observe in the market that a lot of market leaders and a lot of the visionaries in the space have really accepted that data is foundational for building out a modern cloud strategy. Data is essential, and getting that data and integrating and connecting to it and putting it into all one place is essential. So this, I think, is where the industry is heading right now, is saying we understand the data side, we understand getting the data, we need data in one place. Think about data as the source of truth, as the control plane for the physical world. If you define data some way, you want to reflect that in your experiments rather than having the data reflect the experiments the other way around. Also putting everything into the cloud and using that to drive process automation and modeling in a central way. In the most extreme case, building out full digital twins of your process. People understand the value of this and are investing in this more. But the missing piece that we found as we've built out a lot of these systems ourselves and worked with folks that have built out systems like this is the analysis portion. How do you also capture the human in the loop analysis and version that and save that and automate that and thread metadata through it so that you can truly end-to-end capture every single thing that scientists are doing in their analysis, that technicians are doing in QC systems on the factory floor, whatever it may be. And that's where we are heading. So our data integration paradigm and what we oftentimes see, just to reiterate the status quo of best practices of data integration, is syncing data into the cloud the moment it appears, whether that's files on a PC or connecting to an OPC server for machines or connecting to web APIs for applications. Automating data entry then into the system of record to remove human data entry time, to reduce fat finger errors, and automating analysis that can be automated. Lots of times things like outlier detection and simple, straightforward curve fitting can be automated to some extent. But there's so much analysis that still can be automated, and that's the piece that's left over after all of this. And so based on these deep conversations with our clients and our research, we're excited to introduce a full solution for this. So virtualization. Virtualization is a new infrastructure capability that we've introduced to be able to run scientific applications and other applications, effectively any program that you would like, in automation, in Ganymede, and in our cloud as a step in our systems. So when we get data off these PCs for an instrument or wherever the data comes from, we'll save and parse that raw data. But then as a step, rather than automating some analysis and putting it through some code, you may say, oh, I want a human to go review this and have a human in the loop step. I may want to have a human manually do the gating in my flow cytometry. I may want to have the human manually check if the curve fits look right. I want to have the human manually inspect the peaks here and see if it makes sense in my mass spec, whatever it may be. And so we will support having those applications that they would otherwise use at the lab bench or installed on a computer in a virtual machine in Ganymede. And when we run those virtual machines with these applications installed, they exist just for the moment that things are being run, just for that one analysis, and then they disappear afterwards. And they can either be run automatically behind the scenes if you want to just automate some behavior of that analysis app, or users can screen share in via the Ganymede web app for human-in-the-loop analysis and going into do the same inspection and analysis and thoughtful science that they're doing today, but in a way that can be done from anywhere in the cloud, just via the browser, and extracts them from the wet lab. So it also helps unblock usage of instruments so that once people run the instrument, they can then immediately leave the lab and do everything from their desk. And this allows us to treat that human-in-the-loop analysis step as just a function. We can thread metadata through, we can understand the A to B of saying, okay, the input data, the output data, we can link those together because we know exactly what was run in this virtualized environment. So now finally, these programs are also fully automated as a part of the process, completing the entire loop of automating your lab or your facility. A particular example that we'll give a demonstration of today is for flow cytometry. A lot of this is inspired by flow cytometry, which, as we found, is a place that we specialize because it's one of the hardest things to automate out there. In many ways, the data from flow cytometry itself is very complex. You never know exactly what sorts of channels and details you're getting from the machine. Even within a machine, you may configure it differently and different data may come out. So that's where our ability to rapidly integrate and update integrations in code and handle very complex dynamic data sets has already been quite useful. But for the complete Ganymede workflow now with virtualization, we can say we will allow the instrument itself, if we can get this access to control the instrument, to be kicked off from an app or a form or the instrument itself, perhaps in the software, allowing us to know what sample ID is being used and track that as metadata along with anything else throughout the process. We will then kick it off and can include other metadata, like oftentimes plate maps are extremely important to include as part of this. And then our agents, which take a variety of forms, but in this case are likely a PC-based program sitting on that computer attached to the flow cytometer, can kick it off, can wait for the data to come out, and then can get the FCS files or whatever it is off of that. And then we'll put the raw files into Ganymede. And now, since gating of flow cytometry is an analysis that scientists always want to look at themselves and manually do. We can say now that rather than having to go separately, run it through FlowJo or FCS Express or whatever it may be, and then associate that after the fact, that can be run within Ganymede and automatically be associated, allowing them to do that analysis from anywhere. And then, of course, once we get the output of that analysis from the virtualized VM, the VM goes away, and that data can be put into the system of record, as well as a full copy of all the data, all the files, everything can be synced into clients' data lakes. So without further ado, I will turn it over to Nathan Ballou to show a little bit of how this works.
Great. Welcome, everyone. Let me go ahead and share my screen here. Entire screen share. Okay. And we're going to go ahead and get started. Today, we're going to take a look at a couple of different options that we have for flow cytometry, both an automated gating flow and then using the virtualization. So if you were at the first webinar, a little bit of this first part will be review, but we want to make sure that everyone gets a sense of what the Ganymede platform is from the get-go. So what you're going to see here is sort of an input screen that allows you to add files to Ganymede and then kick off runs. So what I'm going to do here is I'm going to take some files and I'm going to drag all these FCS files into here. And then the screen that's going to pop up is actually going to be something that says existing file treatment. So what this is showing is that I've run these files before when I tested out this the webinar flow, and Ganymede saves everything that it touches. So if you put a file into Ganymede, it will automatically be saved. That's great for if you need that traceability. It's a central source of truth. And so when I tried to run these files again, it noticed that these files already existed, and so it asked me what I want to do. In this case, I'm going to click Use Existing, but I could also create a new version if, for instance, you had a similar file, but you want to do a little bit of different analysis on it. And then all I'm going to do here is click Run. And what this is going to do is it's going to kick off some processing steps in the background. This particular, what we call a flow, is for doing automated gating. And so I'll kind of show exactly what that looks like here. If I go to my flow editor, I can take a look and see exactly what's happening in the background when I run that flow. So in this particular example, what we're doing is we're reading in these FCS files, we're performing some automated gating, we're calculating a dose response based upon those FCS files, and then we're plotting some various things, and then we're writing it out to an ELN proxy, in this case, CODA. So when you see these, each one of these we call a node, and each one of these is a unit of code and computation. So you can think of this as just a snippet that is run in a sequence in order to process those files. So we took in those FCS files, we went ahead and read them. Again, we're going to do the automated gating, and I'll show you what that looks like. But for a lot of these, we have a huge selection of different nodes that are available. That are based upon various instruments, file types, whatever you happen to need. And you can drag and drop those over into Ganymede and use them as sort of a low-code option. So you might need to make a little bit of a tweak to them, but they're generally going to work for that particular instrument. But if you want to do a little bit further analysis on the data that you have, what you can do is you can click onto this little icon, and you can see it's on every single node. That'll allow you to view the actual backing code that's associated with this node. So if I take a look at this automated gating node, what's going to happen is it's going to pop up a Jupyter notebook that allows me to modify exactly how that node works. So in this case, we have a SQL query that selects some data from the data lake. We're going to apply just a simple density gate. This is a relatively simple example, but I'm sure you could extrapolate this into a more complex example where you might use machine learning, or you might use more advanced gating strategies in an automated fashion, and then it just applies that gate. Everything in here is version controlled. So if you run the save pipeline code node, it'll automatically be pushed to Git. So you have a full record of everything that you've done in the code. And then it'll run when you run it the next time in the flow. So if we go back here, the thing that I'm going to show next is the tables that are coming out of each one of these files or each one of these nodes. So as you can see, when we ran this node, the read FCS files, it actually outputted a variety of tables. We have various metadata. We've got the raw data itself. We've got the additional metadata, and we want to keep track of all of that. Ganymede, when it's in production mode, actually keeps everything that you've put through a run, and it saves it. So what that means is that every run that you have of this particular flow will have all of this data appended to the end of a table, so that you can always go back, you can take a look at previous runs, and you have that full traceability of record there. So let's go ahead and take a look and see what happened as a result of this flow. So we'll go to Coda, and I'll take a look at my flow cytometry demo, and we'll look at the automated gating that we did here. So we can see that we applied a density gate with an 80% threshold. This is just a graph of that particular gate. It may not be exactly what you would do manually, but it gets you pretty close. You can obviously tweak these in the code as you need to. And then from that gate, we got a dose response. Each one of those FCS files was under a specific dosing. And so we can see that as the dosing goes up, we get a more response through it. So that's our automated gating demo. But what if you want to actually do this in a little bit more manual step? Well, what I'm going to do is I'm going to go over here to our applications tab, and it's going to pop up actually a full VM within the software. I've got kind of an admin version of this, so I can run multiple pieces of software at the same time. But realistically, this would be a little bit ephemeral, so that you could go through this step as you were going in. So what I'm going to do, I've got FlowJo open here. I'm going to add some samples. In this case, just the data that we used before. And we're going to take a look at it. We're going to do some really basic gating, just kind of showing that I don't want to show off FlowJo, but just that you can do all this stuff within Ganymede. So I'll apply a basic gate, and we'll just click OK. And then I'll apply that to everything. So this might be a really basic way that you're interacting with things. But it's not just FlowJo that we can run here. For instance, if you wanted to run FCS Express, we also have that as an option. As you can see here, this is a full version of FCS Express. If I change any one of these gates, it modifies the rest of the values, just like you would expect. We've got here our scatter, and then we've got some histograms, and then we have the dose response curves that are coming out of this. So this is all great. We've got all the data. We're doing the manipulation in this virtual machine. But what do we do when we want to get the data off and do some additional processing? Well, that's when agents come in. So we've got this machine connected to what we call an agent that allows it to automatically take, for instance, an export file from this virtual machine and run some additional processing on it. So if I go here to export, I'll just export a CSV, and we'll call it demo, and I will click save. And with that, what's happening in the background is that it's actually kicking off an additional flow in Ganymede. So if I take a look at flow runs, and I go to the flow that I'm running here, we can see that this flow is now running. So what all this is doing here is taking that CSV file that came out of FCS Express, and it's going to turn it into Coda. If we take a look, at this particular flow, it's very simple. We're just taking that CSV and writing it out to Coda. So if we go over, as soon as this flow finishes running, we can take a look at the Coda entry that's associated with it, and see that we outputted all that data that we just had. So we have the dose response curves. Here I've got it on a log plot. We can also do it on just a linear plot, so that you can kind of see the distinction, is particularly when these values sort of level out. And we have all the raw results. So everything is linked here. This allows you to use that virtual machine as an intermediate step so that you can do your manual analysis. And with that, I'll kind of pass it back to Nathan. I know that was a really quick overview, but hopefully it gave you a sense of our new capabilities with having that virtual machine right in the middle of an analysis step.
Cool, thank you. Yeah, that I think is tremendously exciting to see that manifesting like that and being able to cover cases that otherwise just can't be automated. I will go ahead and go back here. So hopefully that gives you a good idea of the general structure of what virtualization is as a product. We're able to load in any program onto that Windows machine environment, subject to the licensing regime of the program and what you have contracted with the vendor. But otherwise, the capabilities are pretty powerful across Windows, Linux environments. And so I wanted to give an idea of a few different ways that you could think about using this. So we looked at flow cytometry there. We can certainly run applications there. That's one of the best use cases for things like FCX Express, FlowJo, and so on. High throughput screening is another great example of this because that's another case where, although you may want to have curve fitting automated in theory, in practice, everyone always wants to go look at it manually and either define it manually or at least exclude or decide what points to include in the analysis. So we can virtualize apps like Prism, Spotfire, Jump, again, anything that would run in a Windows environment. We can virtualize it there. And this is in addition to, if you have cloud-based versions of this, of course, we can just connect to their API directly. That's the traditional Ganymede way of doing something like this. But many things only run on Windows, or you may only have a license to run it locally on Windows. So we can either let humans go in and do the curve fitting themselves, or even depending on the capabilities of the program, we can preload a configuration. We can have it do a curve fit, or with flow cytometry, we could have it do a gating regime and then have someone go in and check, do I like this? Ultimately, whatever the program interaction is allowed, we can set that up as a canned environment to accelerate the analysis itself. That then allows all of this analysis to be traced from the raw data to the analysis outputs and know what was done there and know what sample ID is associated with everything, so that the full end-to-end can be associated without humans having to go manually tag their data or put things like sample IDs or batch IDs into their file names, which is in 2023 not something that people should have to do anymore. And one of the biggest benefits of all of this is that you can audit and rerun that curve fit from anywhere in the world. You can do it from anywhere in the world. You're now fully freed from the wet lab. And so that's pretty powerful, especially in environments like LC and MS, for instance. With mass spectrometry, those instruments are tremendously important to keep at maximum utilization. And anytime you have someone standing near the instrument, even if it's at a separate PC, just being physically around there, that blocks physically other scientists from going in and running their analyses. So you need to get people physically out of that environment. And then virtualization can also help expedite the analysis itself by having various analysis packages, academic tools, search algorithms preloaded based on what analysis people want to do. And finally, there's many, many use cases for this, and virtualization is especially powerful for some of the more niche, uncommon analyses that people may be doing or in specific fields. Many of the most common applications are pretty cloud native and cloud-based these days, so may not require this. But in more niche fields, technology often lags behind. And so apps for things like material science or chemistry, we find that this is a particularly powerful approach there, because those sorts of cases, people oftentimes are also doing some sort of curve fit or statistical analysis that they may want automated or have some human in the loop analysis with, but file formats are often locked down. You have to have virtualization or have the program in some way to open up the data from the manufacturer. So this is where this becomes powerful, as well as if the data and the file formats from the vendor, from the instrument manufacturer are not open, now you can effectively coerce them into being open by automatically opening something in virtualization in the background and then exporting it as something like a CSV or whatever their export format is. So hopefully that gives you a good idea of some of the use cases. And now, just to bookend this a little bit with how Ganymede thinks about integration as a whole, I'll reemphasize virtualization is so critical for our vision of fully integrating everything end to end and building the fundamental tools of connectivity and infrastructure for this innovation in the space. So our 3 pillars of integration from our perspective are: 1, get the data. You have to be able to integrate everything. That means getting the data from instruments, that means getting the data from machinery, from apps, from databases, and putting it all in one place in a fair format. So not just having and collecting the data, but also parsing it into a standard tabular format. That's what we do. And then once you have it in that format, it makes it easy to analyze. We support arbitrary Python. We'll be adding support in the future for things like R. That makes it easy to work on your data. Now that it's connected, work on it just as if it were almost like a bioinformatics environment or a scripting environment to build the automated analysis and the mapping from A to B, because the business logic also can be so complex to map data from A to B. You really need full code. And finally, automate what you want to do with that data. So oftentimes that might be pushing it into an ELN or a LIMS on the R&D side, something like an MES or a QMS or your data lake on the more manufacturing production side, whatever it is. Our integrations will also help you get it there. And virtualization really completes this, because virtualization allows us to not just analyze or transform the data automatically in code, but allow users to use whatever their preferred app is, whatever the capabilities are, and have that be part of the process. So this is our philosophy of how we want to approach science and industry 4.0. Lab as code is our overall platform approach. And when Ganymede interfaces with things, we have our agents, which provide connectivity to instruments, to applications, to everything. Those agents serve data into our cloud. And then once data is in our cloud, we can automate the analysis and processing of it in our Lab as Code platform, put it where it needs to go, again, into one of those ELN, LIMS, MES, et cetera, systems of record, and we save all the data along the way. So if you have a data lake, we can push it into your data lake, but if you don't, we build a data lake for you as we go, so that everything can be available. And you can then apply standardization and harmonization on top of that by importing things like schemas or ontologies from external sources. Our cloud product lines, based on the new virtualization launch now, break down as Lab as Code, the core mapping and ability to write code against anything in your lab. Our universal integration agents, each of the moons of Jupyter, where we can connect to PCs, we can connect to OPC, we can connect to APIs, files, databases, anything. If it's there, we want to provide the connectivity to it. The core data lake itself, one single fair data environment across everything that is touched and integrated. And then finally now, virtualization, the ability to run anything, not just code, but full applications and full VMs on top of this. This is all powered by our managed services, where although this is a very powerful tool for you to use yourself to build your company on top of, we also provide full service implementation to completely build out the integrations for you. So at the end of the day, all of this has always been about accelerating science. And the way that we think about measuring the acceleration of science is in 2 ways, fundamentally. One is we have to accelerate time to your goal, whether that's an IND, to clinical trials, time to market, accelerating the scientists and reducing these experimental cycles through things like reducing errors, improving asset utilization, and so on. We want to take out at least 10% of that time. You know, if scientists are spending 20 to 40% of their time on manually manipulating data, moving data from A to B, and so on, we can cut out half of that. And then also introduce the other side here, which is cost savings. It should not be the case that you have to vastly overhire to accelerate. There needs to be a way to apply technology to accelerate your science and do it in a cost-effective way. And so by reducing time to market and accelerating scientists, we can also reduce the number of scientists needed to accomplish major things and give higher leverage to the key scientists in your lab. So that's it. We'll switch to Q&A here. I'll leave this on one additional slide here that I want to go over. So just reiterating the structure of this for folks from a technical background, this is something that virtualization is a very, very complex product, and you can analogize it to how you might build it in something like AWS. you'd have to connect all sorts of different tools like AppStream, EC2, Lambdas, S3, Athena, API Gateway to even start getting towards something like this. That's where Ganymede really focuses on producing the exact right infrastructure for the industry here. These VMs are just one time for the analysis. They're created when the user goes into them, and they're destroyed afterwards. So they're not a replacement for your scientist computer itself. They're just a portal to go do this analysis. So this enhances security as well as cost efficiency, since VMs are not running permanently. And multiple users can be going on the same infrastructure. One thing we'll emphasize is that Ganymede is your infrastructure. So anything that is put into virtualization is bring your own license. So this is subject to your licensing agreements with the software vendors. And we want to make sure that the licensing of apps running in virtualization respect the licensing regime of the vendors. So this is something where we will be very careful and work with you to make sure that no licensing is being bypassed. The Ganymede user that's authenticated should tie into the user that has the license to the particular application. And then finally, we can evaluate apps on a case-by-case basis. If this is something interesting to you, please reach out and we'd be happy to comment on particular use cases you may have. And we are now offering virtualization in managed deployments where we're doing the full managed services and integrations, and we'll be rolling out a self-service version of it later this year. So again, very excited to roll this out, and please get in contact with us if you have any questions. But we can turn it over to questions and discussion here if there's anything. Let me see the chat here. Is the software 21 CFR Part 11 compliant? Yes, it can be made to be so. Virtualization is a new product, and so we haven't run it through that yet at this point. But I would expect that it generally is, because in terms of 21 CFR, there's really two components. One is, do you save everything forever, or at least save everything in a reasonable way? And that's exactly what Ganymede helps with. Ganymede is very strict about saying all data is saved forever. It's append only. We always have full traceability from every step. We know exactly what code ran or what version of the program ran. We know what the virtualization that ran was. And so that helps a lot with that. And so we would be happy to, as we roll this out, work on some qualification with folks. And then in terms of e-signature, that's not something that Ganymede offers. That's something that needs to live in your system of record, your ELN or your batch record, depending on your use case. So we fully expect that it should be, but that's not something we've evaluated yet and would be happy to work with folks on. And then there's a question around, are we using established public domain metadata standards in the data backplane? So the short answer is actually, the system itself doesn't enforce any particular standard. It allows you to pick the standard that you want. We're pretty big on the idea that there's many different competing data standards, and it's hard to always standardize your data. So you may want to standardize your data, and that's where you can pull in some public ontology or data structure if you would like, or use some standards, and we can help with that. But we don't enforce it by default, because oftentimes people just need to get the data map from A to B, and it's in their own idiosyncratic format. So it's really subject to what the client wants, but we definitely have that capability. Cool. Any other questions? One more question. Do we store the full IRI of terms from an ontology? Anything that we get from the ontology, we'll store. The ontology itself to us is a file. And so any data from that we'll have available. One of the things about Ganymede is that Ganymede is somewhat Unix-like, to get a little nerdy on it, where all data and all files are stored, in all code are just files from our perspective. And so whenever you have code, for instance, that's versioned in Git in the backend, we build the GitHub repo for every client. And so in that sense, that data is stored permanently, but also anything from an ontology, depending on what the structure is, we'll have all of that available, because we'll import it as a file and have that mapping available. So in that sense, we may scientifically map data from A to B, but we may also be doing this sort of meta mapping of understanding exactly how different data mappings are standardized and where that traces back to in the hierarchy of things like ontologies or metadata on the ontology itself. Everything is just a table or a file. Can we speak on the performance aspects of moving large data files like flow cytometry or mass spec to the cloud from the instrument? What are the minimum network requirements for the lab? So we definitely do both quite large files. We can pretty easily scale up to things like gigabytes of data, and can also talk if you have terabytes of data, things like imaging. We have strategies for that and can work with you on that. Ultimately, the network requirements for the lab usually don't need to be too crazy beyond what you already have, because we can meter out the uploads over time. That's one of the things that Ganymede systems help with, is if there's a constraint or bottleneck on something, we're pretty good about managing and retrying and chunking out those uploads. So you don't need to be able to upload all 5 gigabytes of your flow cytometry across your whole company in one batch in the day. We'll stream it out over time. So generally speaking, if you have a standard 10 to 100 megabit per second internet connection, there should be no problem. If you do have something that's much more constrained, we'd be happy to talk and consult on that. But flow cytometry data generally actually is not that huge. It's on the order of hundreds of kilobytes, megabytes, depending on how big your flow cytometry files are. Even if you multiplex that across like a 96-well plate, you're still only talking hundreds of megabytes. And so it can only take up to, I would say, minutes usually for that to egress the network. And then similarly, our flows we like to say run in human time. So they'll run on the order of seconds or low minutes for that kind of stuff. And so you can get the data from A to B on the order of minutes, even for that kind of medium-sized data, to allow users to press the button, run the instrument, and then immediately turn over to whatever analysis app or something they want to use. Mass spec data certainly can get bigger, but even then, we'll meter it out, and usually it doesn't take too long. The only case where it really gets difficult is if you have large imaging files that get into the gigabytes themselves, or you're doing like terabyte a day kind of things, and that's usually where we can work with other infrastructure setups to help manage that. Cool. Well, thank you all for the great questions here. Please feel free to reach out to myself or Alan or Nathan Ballou anytime. And I will turn it back to Alan here to close up.
Thank you, Nathan. Well, I should say thank you to both of the Nathans for the wonderful presentation and demo. And also thank you to everyone that joined. I added one more fun poll question just to get your thoughts on what you might want to see from us next. As Nathan pointed out, if you'd like to learn more about our platform or some of the new data analysis products like virtualization, or you just want to chat, consult with us about lab data strategy and management, don't hesitate to schedule a call with our team. You can do that on our website. You can also reach out to me personally. So if you haven't already gotten an email from me, my address is pretty easy to remember. It's just alan@ganymede.bio. I'll note that next week we'll be in BioIT World in Boston, and the week after that we'll be at SynBioBeta in the Bay Area. So if you're attending either of those, make sure to check out Nathan's talks at both, as well as stop by our booth. We're also hosting a happy hour during BioIT World and a dinner during SynBioBeta that's open to anyone in town who'd like to meet. And here, I'll drop the link to register for the happy hour at least into the chat. And then if you're not attending either, that's not a problem. You can just reach out to us and we can set up some time to connect in person. It's always nice. As powerful as Zoom is, it's great to have that face-to-face. And then last but not least, just make sure to sign up for our Telescope. It's our blog newsletter. So that's where we share the latest news on Ganymede and our views on software and biotech. And then I can drop a link to that as well into the chat. And yeah, so thank you again, and hope to see all of you again next time. Have a great one.
Thank you.